Imagine looking up at the night sky and realizing it's not empty. It's crowded with billions of stars, each one potentially hosting planets, and yet, when we ask the simplest question, are we alone? The universe returns only silence. This contradiction is one of the biggest mysteries humans have ever faced. It's called the Fermi Paradox. The math says the galaxy should be full of life, but where is everybody? In this video, we're diving deep. We'll walk through the smartest explanations scientists and thinkers have suggested, from self-destructing civilizations and hidden cosmic zookeepers, to the possibility that we're simply looking in the wrong time. By the end, you might not know the answer, but you'll never look at the sky the same way again. First, let's understand the scale. Our galaxy, the Milky Way, contains roughly 100 to 400 billion stars. There are hundreds of billions of galaxies in the observable universe. Even if only a tiny fraction of stars have planets in the habitable zone, the numbers still explode. So, Enrico Fermi's simple question in the 1952nd, "Where is everybody?" is startling. If life and intelligence are not incredibly rare, then the universe should be teeming with technological civilizations. They should be visible, leaving traces in the sky, radio signals, or massive engineering works. Yet we see near zero obvious evidence. That silence forces us to consider deeper possibilities, which leads us to our first major idea. One explanation is called the Great Filter. The idea, somewhere between dead matter and interstellar civilization, there is one or more extremely unlikely steps. Maybe most planets never get life. Maybe life rarely becomes intelligent. Maybe intelligence rarely becomes long-lived. If the Great Filter lies mostly behind us, meaning complex life and intelligence are extraordinarily rare, then we might be uniquely lucky. Earth could be an unbelievably rare oasis. But what if the Great Filter lies ahead of us? That's the darker possibility. Civilizations commonly arise but destroy themselves before escaping their planet. Nuclear war, runaway climate collapse, engineered pandemics, or uncontrolled AI could wipe out intelligent life before they ever get to light-speed travel. That idea is sobering. It means the silence might be a cosmic warning. The universe is full of short-lived sparks that burn out quickly, and the timescale to become a long-lasting, spacefaring civilization is brutal. Now for a weirder idea. The zoo hypothesis. Maybe advanced civilizations exist, but they deliberately avoid contact with us. Picture Earth as a protected nature reserve, watched but not touched. The logic, interfering with less advanced cultures, could be unethical or risky, so a cosmic community agrees to quarantine us. In this scenario, evidence might be deliberately hidden, or contact only occurs under strict conditions. That would explain why we don't see obvious probes or galaxy-spanning megastructures. The advanced civilizations maintain a policy of non-interference. This idea raises philosophical questions. Would we even be able to recognize an alien civilization's code of ethics? And would silence mean benevolence, or an ominous experiment we don't yet understand? Some argue the silence is false. We have seen them. Unidentified aerial phenomena, UAPs, are part of official government discussions. In recent years, leaked reports and declassified footage have renewed public interest. People point to eyewitness accounts, radar tracks, and objects that defy conventional explanation. But extraordinary claims need extraordinary proof. Most UAP cases have plausible terrestrial explanations: sensor errors, secret aircraft, optical illusions. And even if a tiny fraction remains unexplained, that doesn't prove intelligent extraterrestrial origin. There's also the idea of covert contact. Maybe governments know more than they tell. That's possible in fiction, but if a global conspiracy existed to hide contact, keeping dozens or hundreds of technologies secret without leaks seems unlikely on human timescales. Still, the UAP discussion remains one of the most charged modern debates about alien life. Here's another angle. Maybe civilizations are abundant, but they don't overlap in time. The universe is 13.8 billion years old. A civilization that rose and fell a billion years ago leaves ruins we might not recognize. We may be early too soon to meet others, or late after many others have risen and fallen. Civilizations might blink in cosmic time, appearing and disappearing long before we develop the technology to see their traces. It's like trying to meet someone on a highway at night. By waving a flashlight for 10 seconds, the chances of overlap are tiny. This temporal mismatch makes the Fermi Paradox even more plausible. The cosmos is full of civilizations, but rarely at the same time and place as us. A related idea argues that Earth's combination of factors is incredibly rare. The rare Earth hypothesis notes how many conditions had to align: a stable star, the right distance, plate tectonics, a large moon stabilizing axial tilt, magnetic field shielding from cosmic rays, and a long period without catastrophic sterilizing impacts. If even one of these is uncommon, complex life could be extremely rare. It's not romantic, it's statistical. In that case, the silence simply reflects our unique luck. Life flourished here and maybe almost nowhere else. A practical point. Maybe we simply haven't looked in the right way. We mostly scanned the sky for radio waves because that's what we could search for early on. But advanced civilizations might use communication forms we don't yet understand: neutrino beams, quantum entanglement, or compressed data in dark regions of the spectrum. Astronomers now search for technosignatures, industrial pollutants in exoplanet atmospheres, unusual light curves that might indicate megastructures, or infrared heat signatures of massive engineering projects. As our instruments improve, our ability to detect non-radio signs grows. So some silence is just a limit of our technology, and imagination, we might be blind to the right clues. Another subtle point: intelligence doesn't necessarily equal technology. Animals on Earth show complex behavior and intelligence without building radio transmitters. An alien mind could be distributed, non-material, or simply uninterested in outward expansion. Their priorities might be beyond our comprehension. So, we might be asking the wrong question. Instead of, "Where are the aliens?" maybe we should ask, "What forms can intelligence take?" The assumption that intelligence must look like us building cities, lights, and radio may be deeply human-centric. Some thinkers go further. The simulation hypothesis suggests our universe could be a simulation where other intelligences are either absent or intentionally hidden. Others speculate that sentient life develops inward, becoming virtual rather than physical, and therefore invisible to our telescopes. These ideas may sound fringe, but they force us to acknowledge that our intuitions about life and visibility are limited. Sometimes the greatest advances come when we accept that our questions need rewriting. So what now? Scientists are doing concrete work. New telescopes, like James Webb and the next-generation radio arrays, are dramatically improving our view. Missions to Europa, Enceladus, and Mars probe for microbial life in our solar backyard. SETI projects now search for technosignatures beyond radio.
This could be it.
I think you're right.
Importantly, as we develop better AI and data analysis, we can comb enormous data sets for anomalies that humans would miss. The future of the search is methodical, patient, and increasingly sophisticated. We've walked through the biggest explanations: the Great Filter, hidden observers, temporal mismatch, rare Earth, the limits of our search, and more speculative ideas. Each of these is plausible in its way. The silence may be a cosmic warning, a sign of our uniqueness, or simply evidence we need better tools. For now, the sky keeps its secrets. But the very fact we ask the question, the very fact we build better eyes to stare into the dark, that is the human story. Curiosity pushes us forward. And perhaps one day, that curiosity will be answered. So, are we alone? I don't know, but I do know this. The search itself is one of the most profound adventures humanity has ever launched. If you like this deep dive, subscribe to History and Beyond. We'll keep asking the big questions. What do you think? Drop your theory below. Are we hidden, rare, early, or something else entirely?